Good morning, everyone. Welcome to Nike's Programming World. So, today we are going to discuss an important chapter, particularly in mathematics, which is useful for both in mathematics and also for those who are preparing or who are planning to make a career in machine learning and artificial intelligence. And that too, this type of math is very important there. So, today we are going to discuss vector calculus. Okay, now we'll just start with Green's theorem, and we have particularly three important theorems in vector calculus, particularly Green's theorem, Stokes theorem, and Gauss divergence theorem. Right now, we'll start with the Green's theorem. Now, yeah, see here. Let me read the statement first. Here, the Green's theorem statement: if u comma v comma dou u by dou y and dou v by dou x are continuous and single valued functions of xy in a closed region R enclosed by a curve C, then the theorem is defined as follows. So this is very important equation. Integral over the curve u dx plus v dy is equal to double integral dou v by dou x minus dou u by dou y dx dy. Dou v by dou x minus dou u by dou y dx dy. Okay, please remember this equation, Green's theorem equation. Okay, I am just highlighting the equation part particularly. Yeah, see here. Yeah, I'm repeating once again, integral over the closed loop. To be here, I'm adding one important point. Green's theorem, Stokes theorem, and Gauss divergence theorem are used and valid only for closed boundaries or closed regions only. Okay, so now the equation is as follows. So integral over the closed loop on the curve u dx plus v dy, u dx plus v dy is equal to double integral over the region dou v by dou x. Here u is associated with dx, here v is differentiated with dou x. A slight change here. You can remember it as reciprocals, like that reverse. So dou v by dou x minus dou u by dou y into dx dy. Now we'll start with the basic level problem. Now see here. So let me explain the question first. Verify Green's theorem in the plane for integral x square dx plus xy dy, where c is the curve in the xy plane given by x is equal to 0, y is equal to 0, x is equal to a, and y is equal to a are the limits. Y is equal to a are the limits. Okay, now see here, let me write the question first. Given integral x square dx plus xy dy, x square dx plus xy dy, and given the limits are x is equal to 0 comma y is equal to 0, x is equal to a, and y is equal to a are the limits. Now first, before solving the question, let me write the equation of Green's theorem. That means what we have to do, we have to know how to approach the problem. See, let me write the Green's theorem statement. Green's theorem states that integral over the closed loop u dx plus v dy should be equal to double integral over the region dou v by dou x minus dou u by dou y dx dy. This is the Green's theorem statement. Now with the given limits, let me draw the diagram. See here. First, let me draw the coordinate axis. Now see here. The first limits are x is equal to 0. X is equal to 0 means it is y axis. So it will be the equation x is equal to 0. Okay. Now y is equal to 0 means x axis. So this will be the equation y is equal to 0, and x is equal to a. X is equal to a means, that means here, somewhere here, at a distance of a from the origin, at a distance of a from the origin, and we have to produce it as a line. We have to produce it as a line. So this is our required line, x is equal to a. Always remember one thing, x is equal to a or x is equal to k is a line parallel to y axis, where y is equal to a or y is equal to some constant is a line parallel to x axis. So here y is equal to a means somewhere here at a distance of a. So this line is known as y is equal to a line, y is equal to a line, and we know that point, it is a comma 0, it is a comma a, since because it is a distance of a from y axis and a from x axis, and this point we know that it is 0 comma a, and this point it is known as 0 comma 0, 0 comma 0. Okay, now clearly we got the limits and we got the diagram or a closed loop. Now so let me give the points notations so that we can integrate easily. See here, let me assume this point as O, and this point as A, this point as B, this point as C, this point as C. Now first we have to verify the problem. We have to verify the Green's theorem equation or Green's theorem statement for LHS. So see here, for LHS, that means integral over the closed loop C u dx plus v dy. Okay, so it is formula, but the given question is x square dx plus xy dy. So let me write that. Okay, so no need to write formula again and again. Yeah, so x square dx plus xy dy. Now this thing we have to find out over the entire region, the entire closed loop. That means here C means the entire closed loop OABC. That means we have to find integral over the OA region x square dx plus xy dy, plus we have to find the entire integral over the OA limit is OA line is finished. Now we have to go for AB line. We have to go for AB line. X square dx plus xy dy. Again, AB line is now finished. We have to go in the line of BC. So integral. I'm sorry. Let me address this thing. Yeah. So integral BC x square dx plus xy dy, and integral CO x square dx plus xy dy. That means whenever, if you are solving a problem on Green's theorem, this thing is very important. That means they will be given only the curve closed loop, and you have to find the integral part over the different lines in the closed loop. That means here it is simply given that over the closed loop C x square dx plus xy dy. That means we have to find in the line of OA, and in the line of AB, and in the line of BC, and in the line of CO. Now the closed loop is finished. Now we have to find the integrals of this particular equation separately. Okay, first let me find out the integration over the line OA. See here, I'm using white coloring again. So that is important step. That's why I wrote it in the yellow color line. See here, over the integral OA, x square dx plus xy dy, x square dx plus xy dy, x square dx plus xy dy. Now see here, what is OA line? OA line is nothing but x-axis. That means it is y is equal to 0. OA line is nothing but y is equal to 0. OA line. On the line OA. On line OA, what is it is? It is nothing but x-axis. That means equations y is equal to 0. Equations y is equal to 0. Now write that. Y is equal to 0. Now, if y is equal to 0, what will be the dy? Dy is also 0. Since if we differentiate 0, the answer will also be 0. So, if y is equal to 0, dy is equal to 0. Now, substitute this in the integral part. So, here dy is 0. So, 0 into anything, entire will be 0. So, this part is eliminated. Now, remaining part is x square dx, x square dx, okay, x square dx. Now, here, what is remained? Dx. What is remained? Dx. What is remained here? Dx. Dx means we have to write the limits of x. We have to write limits of x. Now, in the line OA, limits of x are varying from 0 to a, 0 to a. That is very important. That is very important. Okay. Why? While solving the integral over the limit OA, dy is eliminated. The remaining part is only dx. Now, for the dx, we have to write limits of x. And limits of x are varying from 0 to a, 0 to a. Now, we have to solve integration. What is integral x square? It is x cube by 3. Over the limit 0 to a. Over the limit 0 to a. And if you put upper limit, it will be a cube minus lower limit will be 0 cube by 3. So the answer is a cube by 3. Answer is a cube by 3. And in the similar fashion, in the same way, I am separating by a line and I am doing the same thing over the line AB. See here, OA is finished now. In the same way, we have to find the integral for the line AB. Now see here. Okay. Now, along the line AB, along the line AB. Here it is along the line OA. Here it is along the line OA. I wrote it already here. Okay. Now along the line AB. Same to same we have to do in the same manner. Now, the integral function is same. What is the function? X square dx plus xy dy along the line AB. Now we have to check the line AB, what it is. Now AB is a line which is a distance of A from the y axis. That means it is x is equal to A line. It is x is equal to A line. Okay, it is x is equal to A line. See here, I wrote it already here. AB is a line. X is equal to A. X is equal to A. See here. Now on line AB, x is equal to A. X is equal to A. If x is equal to A, what will be the dx? It will be 0. It will be 0. Why? X is equal to A is constant. When we differentiate a constant, the answer will be 0. That means if x is equal to A, dx of A divided dx of A means 0. So dx will be 0. That means this entire part is eliminated. Since dx is 0, this entire part will be eliminated. Now remaining, what is remain here? xy dy. In that also we have to substitute x with a, because already we know that x is equal to a. So it will become integral a into y dy. Integral a into y dy. Since a is constant here, we can write in the outside. So a into integral y dy. A into integral y dy. Since the function is in the dy, we have to write limits of y. We have to write limits of y. See here, along line AB, the limits of y are, here y limits are 0, here y limits are a, here y limits are a, here y limits are 0, here y limits are a. So 0 to a, 0 to a. Now a into, what is integral y? It is y square by 2 over the limit 0 to a. That means, so a by 2 into a square. That means a cube by 2. That means a cube by 2. A cube by 2. So now we have completed the integral part over the lines OA and AB, and the similar way we have to find the integral part over the lines BC and CO. BC and CO. Now along OA line is completed. AB line is completed. Now we have to find integral part over the BC line. Over the BC line. See here. Along the line BC. Along the line BC. Along the line BC. Integral line BC. The function remains same. X square dx plus xy dy. Okay. Now along the line BC means we have to check what is the equation of the line BC. What is the equation of line BC? See here, BC. BC is a line which is having the equation y is equal to a. Y is equal to a. BC line means y is equal to a. Since it is at a distance of a from the x-axis, means the equation is y is equal to a. Right, that y is equal to a. Y is equal to a means dy is equal to 0. Y is equal to a means a is a constant. If we differentiate a constant, we'll get 0. So if y is equal to a means dy is equal to 0. Now just replace it in the respective places. If dy is equal to 0, that means this part will be entered become 0. This part will become 0. Now the only part remained is x square dx. Since the function is in dx, the function is in dx means we have to write x limits. We have to write x limits. Here x limits are varying from, see, we are going in the direction of b to c. We are going in the direction of b to c. From b to c, we are going in the direction of b to c. The arrow mark represents the same. We have to find in a ordered manner. Since it is a loop, we have to find the integral in a ordered manner because it is a loop. OA, AB and BC. Now in BC, the limits of x are varying from a to 0. The limits of x are varying from a to 0. A to 0. Now what is integral x square? It will be x cube by 3. It will be x cube by 3 over the limits a to 0. That means we have to find, we have to put upper limit first, then lower limit. So 0 cube minus a cube by 3. That is equal to minus a cube by 3. Minus a cube by 3. Now in the same fashion, we have to complete the only remaining part. That means, I'm sorry, once again there is some technical error this time. Let me erase this thing. Yeah. Now we have to find the remaining part. That means along the line CO, along the line CO. That means integral over this line CO, x square dx plus xy dy along the line CO. Along the line CO. Yeah, CO. Yeah, CO line is nothing but x is equal to 0. The equation of CO line is x is equal to 0 because CO line is nothing but y axis. The equation of y axis is x is equal to 0. X is equal to 0. First we have to write that x is equal to 0. Since x is equal to 0, dx will be 0. Now substitute here. So dx is 0. That means this entire part will be 0. And also if we put x is equal to 0 here, 0 into anything, this will also become 0. That means integral 0 is nothing but 0. Integral 0 is nothing but 0. Now we got the integral values for all the boundaries for OA, AB, BC and CO. Now we have to add. So that means we already know that integral curved region closed loop x square dx plus xy dy is equal to sum of all these values. Now let me add accordingly. So this 1 and it is 2 and it is 3 and it is 4. So now add accordingly. So it is a cube by 3 plus a cube by 2. A cube by 3 plus a cube by 2 and the third value is minus a cube by 3 and fourth value is 0. Fourth value is 0. Now plus a cube by 3 and minus a cube by 3 is cancelled. The only remaining value is a cube by 2. A cube by 2, right? So now it is finished. The LHS part is finished. Now we have to verify with the value of RHS. Now consider RHS. Consider RHS. Now let me write the equation or the standard formula of Green's theorem again. See what Green's theorem states that integral over the closed loop u dx plus v dy is equal to double integral over the region dou v by dou x minus dou u by dou y dx dy. That means we have to find the uv values. See here, given x dx x square dx plus xy dy. Now comparing with the standard equation u dx plus v dy, we can write as the u value as x square and v value as xy. U value as x square and v value as xy. Now for finding RHS, we need to find what is dou v by dou x and what is dou u by dou y. Now see here, since u is equal to x square, dou u by dou y means dou by dou y of I'm sorry, again the pen here is having some problem. Sorry for the disturbance caused. Yeah, so dou u by dou y means dou by dou y of x square. It will be 0 because when we are differentiating with respect to y, x is a constant, so dou by dou y of x square is equal to 0. Okay, so this value is 0. And similarly, we have to find dou v by dou x. V is equal to xy. So we have to find dou v by dou x. Dou v by dou x means dou by dou x of xy. Dou by dou x of xy. When we are differentiating with respect to x, particularly partial differentiation, y is a constant. When we are differentiating with respect to x, the other variables other than x all are constant. So dou by dou x of xy means it will be y. Now, so this value will be y because dou by dou x of x is 1. So 1 into y is y. So now RHS will become double integral over the region y minus 0. That means y dx dy. Since we have to integrate with respect to dx and also with respect to dy, we have to write the limits of both dx and dy here. So I'll be writing in the next slide. So y dx dy. Yeah. Now from the figure we can clearly say that the x limits are varying from 0 to a. X limits are varying from 0 to a and y limits are varying from 0 to a. Both x limits are varying from 0 to a and y limits are varying from 0 to a. And also we can find it that from question also, x is equal to 0 to a and y is equal to 0 to a. Okay, now just replace here limits. So 0 to a and 0 to a. Now first we will do the integral part, which is inside the integral part. See here, 0 to a y dx. When we are integrating with respect to dx, x is a variable, other than x, y, z are all constants. Here y is there, y is a constant, so I can write as y into integral 0 to a 1 dx. So it will become y into x over the limit 0 to a. So y into upper limit a minus 0 will become a into y, ay. Now we have to replace here. So now it will become 0 to a ay, 0 to a ay dy. Now a is a constant here, write it outside. So 0 to a y dy. So integral y dy means y square by 2. Integral y dy means y square by 2. So y square by 2 again over the limit 0 to a. So a by 2 into upper limit minus lower limit. So a by 2 into a square means a cube by 2. A cube by 2. Right? So it is RHS. And earlier we got LHS value. Yeah. Here, yeah. A cube by 2. It is LHS. Now from the above equations, LHS is equal to RHS, and hence Green's theorem is verified. Green's theorem is verified. Okay, Green's theorem is verified. Okay, yeah.